Okay, so let's look at a second order integrated rate law. A second order integrated rate law. Its rate law would be of this form: K times the concentration of A raised to the second power, right? That is the case for this example reaction here where we have one reactant A, right? We could have two reactants that are both first order, which would still give us an overall second order. But this is just for this example. This is our second order integrated rate law. Now, if we integrate it with respect to time, this is our integrated rate law for a second order reaction, right? Which is also in the form y equals mx plus b. If we solve for our half-life, right, if we plug in 1/2 of the initial concentration of A naught into the concentration of A at time t, we end up with T 1/2 equals 1 over K times the initial concentration of A. So contrary to what we saw with first order reactions, with a second order reaction, the half-life is dependent on the initial concentration of a reactant, right? Which is shown here in the equation. It is dependent on the initial concentration. Here is a graph of an example of a second order reaction. So it also has a linear relationship, but unlike our first order reactions, which had a negative slope, here we have a positive slope, right? We have a positive slope. So our slope is equal to our rate constant K, and our y-intercept is 1 over the initial concentration of A. So a zero order integrated rate law of the same form, A, reactant A to products, our integrated rate law, our rate law would be K times the concentration of A raised to 0, to the 0 power. That reduces to 1, so our rate is basically equal to the rate constant for a zero order reaction. So if we integrate with respect to time, this is the form of our integrated rate law, where our concentration of A at times t equals negative KT plus the initial concentration of A. This is our equation. If we plug in 1/2 of the initial concentration of A into the concentration of A at times t, we would get T 1/2 equals the initial concentration of A over 2K. 2K. So the half-life of a zero order reaction is dependent on the initial concentration of the reactant. So just like with our second order reaction, the half-life is dependent on the initial concentration of reactant. All right, so I'm going to pause here, and in the next video, we'll pick up at collision theory.